have studied the motion of particles, how to find an equation to describe the motion of a particle with constant velocity or with constant acceleration. We also know how to describe the motion and the trajectory of a projectile motion. We know how to find equations of motion and how to study the energy of the particle. There is a very important concept, though, in physics that describes or measures the amount of or the quantity of motion that an object has. This is the momentum p, that is defined as the product of the mass of the object times its velocity. This new magnitude is a vector. It has magnitude and direction, and it changes when the particle collides with another particle. When two particles collide, each one of them will change the velocity, either magnitude or direction. But they can also get stuck together and therefore change the mass. If we assume that the mass of a particle or object does not change, we can calculate the derivative of the momentum with respect to time. We find that the derivative of the momentum with respect to time is mass times acceleration, which it is the force. The change of momentum in time is equal to the external force. So an external force changes the momentum of a particle, and the direction of the change of momentum is the same as that of the external force. The change of momentum will depend on the intensity of the force, but also on the time that the force is acting on the object. We define the impulse on an object as the force acting on that object multiplied by the time the force is acting on the object. If the force is not constant, we will have to integrate J is equal to the integral from initial time to final time of the force times dt. We can also use the average force to calculate the impulse. If we write the force as mass times acceleration, then the impulse is the integral of the mass times acceleration dt, which is v final minus v initial, which is the final momentum minus the initial momentum, which is the change in the momentum.